chapter 11, we are skipping around a bit, so we are actually going to jump to 11.2 to start, and then we're just going to cover sections 2 and 3 out of this. We are doing pretty much all of this chapter on the calculator, so we will do very little by hand.
Nice.
Oh, yeah, yes. Would you like doing our tests on the calculator? Alright. So we have been talking about hypothesis testing. And we know we've done hypothesis testing for a couple different things at this point. We've done it for the mean and for the proportion, right? And it was essentially the same thing. We have to have set up the null and alternative hypothesis. We have to check the criteria, and the criteria depends on what?
Variable testing.
Right, if we're testing with the mean or the proportion. And then we can compute either a t or a z, which again depends on the variable we're testing. And from that, then we have to make our final conclusion. And remember, if our probability is less than alpha, that's when we reject. If the probability is greater than alpha, does that mean we proved the null hypothesis? No, it just means we failed to reject. So with hypothesis testing, we are making the assumption that the null hypothesis is true. And we're basically saying, if the null hypothesis is true, what's the probability of whatever outcome happening? And if it's a small enough chance, then that leads us to believe that the null hypothesis really wasn't true. But if it's a big enough chance, it doesn't mean the null hypothesis was, it just means I can't prove it's not. So we're still talking about hypothesis testing here, but what we're going to look at today is when we have two different samples. So maybe I want to compare the final in my stats class with Mrs. Fuller's Bio 3 final. And I want to be able to look at the means from those two different groups and decide if one's better than the other. Okay, can I just necessarily look straight at the mean? No, because there's differences, right? I can't just say, oh, the mean on my test, they got 120 points, and on her test, they got 560 points. Does that mean that you did better on hers because you got 560 points? Not necessarily, because her tests are worth a lot more points than mine are. So we have to look further into it if we want to compare different sets of data. Today we're going to specifically talk about matched pairs data. So we talked about matched pairs at the beginning. And matched pairs is when I'm not just taking any student from my class and any student from her class, but the same student from two different classes. So they're connected in some way. And I wanted to look at how you particularly did in here versus how you did in there. If we're talking about matched pairs, we have to have random sampling, matched pairs. We're going back to the main criteria that I will ask you to verify on all these is just that the sample is bigger than 30, which is a pretty common criteria that we've seen, and they have to be independent. Most of the time, just like we saw with the other hypothesis testing, I'm not necessarily going to mention all of these things in the problem. So the one criteria that I'm really expecting you to verify is that your sample is at least 30. If the sample isn't bigger than 30, what do you think has to be true about the sample? Has to be normal to begin with. All right. So first step, we will have the null and alternative hypothesis. The null on this one is very similar to what we've seen before. We're talking about the mean, and we had means on our last quiz, but you'll see this mean, and it has a sub D next to it. That's the mean of the difference. So I'm actually going to look at the difference in the test scores from the two classes. So your null will be that the difference is 0. You did the same in both. Then the alternative would be less than, greater than, or not equal to, just like we've seen before. And we'll have some alpha level, which is our basically seriousness of type 1 error. And then we have all the things that we've done before. So when we were talking about the mean, we always found a t-value, which is the mean of the difference divided by the standard deviation. Or if you prefer to think of it, it's just like a z-score, except with a t. It's just like the particular score minus the mean of the difference divided by the standard deviation of the difference when we set that up. And then we can do classical or p-value. Classical is when you find the critical value on the table and see if you're in the shaded region. P-value approach is when we find the probability and check if probability is less than alpha. And p-value is typically our favorite. It's a little bit easier, especially if we're doing the calculator and it gives us that probability. It's pretty easy to check if that's less than alpha. So let's look at an example. The following data represent the cost of a one-night stay in Hampton Inn Hotels and La Quinta Inn Hotels for a random sample of 10 cities. Test the claim that Hampton Inn Hotels are priced differently than La Quinta Hotels at the alpha equals 0.05 level. All right. First of all, if I'm going to treat this as matched pairs data, it has to be matched pairs. Why would this be?
They're all in the same cities.
They're all in the same city. I took one city in each type of hotel in that city, so that's why it's matched pairs. I did not have enough to assume normal, so I should have stated in this problem that it was normal, so let's assume that. That was an error on my part, not including that. Because otherwise I would need at least 30 points. So the null hypothesis is that there is no difference. The mean of the difference is 0. The alternative, I want to check if they are priced differently. So what would my alternative be? Not equal to 0. Okay. To do this, I have all this original data. We need our calculator here. It's just too much to try to do it all by hand. So we're going to go into our calculator and let's enter this in our L1 and the L2. So L1 needs to be all my Hampton Inn, L2 is my La Quinta Inn. We do need to make sure we are putting these in order because they're like ordered pairs because they're matched pairs. But what I am really concerned with is if they are different or not. So I'm going to go to my L3. And you could go through and like physically subtract each of those values to get it. But if you go up on top of the title, L3, so I have it highlighted, we can tell the calculator we want that to be the difference. So we're going to make this L1 minus L2. So if you hit second and the number 1, that's L1 minus second number 2. So it tells me list 3 is list 1 minus list 2. And hit enter. And it will automatically find all of those differences. All right. That is the one piece that is different from what we were doing on our last quiz. I had to find the difference. Now this is just like any other test for the mean. So if we go into stat tests, when we were talking about the mean, which test did we do? 2, the t-test. Okay, we want to base this off data. The mean of the null is 0. My list needs to be the difference, which was L3. So if you hit second number 3, that'll make it L3. Frequency should be set at 1. We're never going to mess with that. We were testing not equal to, and calculate. So if I'm trying to show some work here, my t-value is 5.27. You guys get that? And our probability, it has e -4, so you move the decimal back 4 places. Everybody get those? Then how do we tell if we reject or not? Since p is smaller than alpha, that tells us to reject. If the null hypothesis is true, there is less than a 0.05% chance of getting that outcome, which is very, very unlikely. So we could say there is sufficient evidence to conclude the hotels are priced differently. Does anyone want me to go through the classical approach on this, or are you guys content with this approach? No need to overcomplicate things, right? We can also do confidence intervals. We've checked confidence intervals before. Basically, if our null hypothesis is in the confidence interval, then we can't reject. If it's not, then that would lead us to reject. So if we're building a confidence interval around these, we've done them for the mean before. The mean here would just have to be the mean of the difference, so that third column there. So not the individual data, the difference in the data. And then you could build your confidence interval around that. So let's say I wanted to do a 90% confidence interval for the mean difference in the rooms. So we've done these on the calculator as well, and since we had the original data, we have to put it in the calculator anyway. We might as well do that. So if we go stat tests, if we're talking about the mean, we know we're dealing with t's, and we want an interval. So number 8, the t interval. Okay, this is based off my data. Because we've already told it to do L3, we can use that. We are building a 90% confidence, so 0.9. So, what does that tell me? We are 90% confident the price difference is somewhere between $33 and $69. Is 0 included in that? No. So if we're 90% confident it's somewhere between these, the null hypothesis isn't in there, that would again lead us to reject. You also have the option of doing your confidence interval by hand, just like we've done before. But you would have to use your calculator to get some of it. You would have to get the mean and standard deviation for the difference. So for L3, so you'd have to go to the one variable statistics for L3, get your mean, standard deviation, and then when we go to look up the t-value on the table, how many degrees of freedom would we have? 9, because there were 10 points, so it's always one less for the degrees of freedom.
Are you gonna have us do it by hand on the test?
Probably not. We've done confidence intervals by hand before, so at this point, since we'll probably just do them on the calculator. Yes.
Is the, like, what did we put in for, like a list?
What did we put in? Okay, we're going to look at this one question here. Problem number 9. My document camera won't zoom in enough, but. So, it is a commonly held belief that SUVs are safer than cars. If an SUV and car are in a collision, does the SUV sustain less damage as suggested by the cost of repair? So, we have, the types of vehicles here, the amount of damage to the SUV in dollars, the amount of damage to the car in dollars. Why is this matched pairs?
Because you're checking the damage of the SUV compared to the car.
Right, and they were in an accident together. It's not like I took an SUV from an accident over here and a car from an accident over here and compared them. They were in the same accident. So on your calculator, go ahead and enter these into our lists. So L1 will be my SUV. And we need to write down a null and an alternative, but I'll wait until you get your data before I do that. So we are trying to decide, I'm going to do part C. Does the data suggest the repair cost for the car is higher? So my mean, or my null, would be the mean difference is 0. The alternative. We have to decide what that would be. If I want to know if the car is higher, when we do the difference, the L1 minus L2 for the difference. If the car is higher, what kind of number are you going to get? A negative. If you do SUV minus car, and car is higher, then we get a negative. So my alternative would be that the mean difference is less than 0. So then does everyone have it entered into L1, L2, and you set your L3 to be the difference? So then we can go stat tests number 2, basing it off data. Mean of the null is 0. The list should be L3. We were checking less than 0. and calculate. So I get a t of negative 2.685, my probability 0.018. We're checking if the car was higher at the 0.05 level. So alpha is 0.05. So what does this tell me? P is less than alpha, which means there is enough evidence to conclude the mean car repair costs are higher. Is that okay with everyone? I have a packet for this chapter, just like we have been doing.